This question is asking about perchloric acid, which is one of the strong acids I require you, my students, to memorize. Perchloric acid, because it's a strong acid, dissociates in a virtually one-way arrow, so I don't have an equilibrium arrow here to form H plus and ClO4 minus. It tells me that I have a solution of this that is 0.250 molar in concentration, and I add 5 milliliters of it. That's interesting information. Why do I even care? Well, the original question is actually asking me to determine what the pH of this solution is. And the pH, we should remember, is equal to negative log of the H plus concentration. So what I'm trying to get at is what is the concentration of H plus. If I can figure that out, I can throw that number in there and then I get my pH. So, keeping in mind the concentration of H plus is going to be equal to moles of H plus divided by liters of solution. I need to figure out how many moles of H plus am I going to get if I take 0.25, or if I take 5 milliliters of a 0.25 molar solution. So I'm going to go ahead and write milliliters here. I want to convert that to liters, so I'll write milliliters in the denominator, liters in the numerator. 1 liter has 1,000 milliliters. That will get me to liters. Now what? Well, I want to get to moles of H plus, so I'll go ahead and write down liters in the denominator and 0.250 moles of HClO4. In this solution, I've got 0.250 moles of HCl4 in 1 liter of this solution. The liters cancel each other out, the mils cancel each other out. How does that get me to moles of H+? Well, if you look at the stoichiometry of this reaction, there's 1 mole of H+ for every 1 mole of HClO4. Does that make sense? So moles of HCl4 cancel each other out, and that leaves me with moles of H+. When I throw that into my calculator, I end up getting 0.00125. So that's how many moles of H plus I have thrown into the solution when I threw 5 milliliters of 0.25 molar perchloric acid. I now have moles of H plus, but I now have to figure out how many liters of solution. It tells me in this problem that once I've done that, I dilute the solution to 50 milliliters. That includes the 5 milliliters that we've already added. It just says that we add additional water up until we hit 50 milliliters. So the final number of liters of solution is, well, it's 50 milliliters. I convert that to liters, of course, by dividing by 1,000. Hopefully you're okay with that. That ends up being 0.05 liters. So, moles of hydrogen up here, or moles of proton. I've got my total number of liters of solution is 0.05 liters. That is the concentration of H+. You can throw that into your calculator. You get that number, you then put it right here and throw that into your calculator, and that will give you your final pH.